Welcome to my YouTube channel. In today's video, I will explain you about UART protocol in ESP32 hardware. So, before going in detail, if you haven't watched my previous videos, I highly recommend you to watch my previous videos that is relevant to some of the important topics on ESP-IDF program. So if you haven't subscribed my channel, please do that because that will encourage me to do more videos related to ESP-IDF program. And also if you want to reach me, you can reach me through my Fiverr account and also through my email if you want any help on your project. So this details is under the description in every video. So let's go back to our main topic. So what is UART? UART stands for Universal Asynchronous Receiver Transmitter. So it is a hardware protocol that is mainly used to communicate between hardware devices. So as you can see in this figure, if we have two hardware devices with UART capability, we can connect those UART for input and communicate in between the device. So what is asynchronous? So as you can see in this figure, there's no dedicated clock signal in this UART connection. So that means the sender and the receiver should have agreed to a common baud rate value. It, it happened because there's no dedicated clock signal that is connected in between two devices. So that is the reason why we call UART is asynchronous communication protocol. And as you can see here, when you are connecting two devices uh, on serial interface, uh, so you have to connect the transmitter of one device to receiver of the other device, and in other way, the receiver of the first device should be connected to transmitter of the other device. So when you are connecting to uh, two devices, so you have to make sure the pre-configuration is correctly done. Otherwise, the UART won't work. So let's get back to the programming side. And before that, if you want to learn more about the UART protocol in ESP32, you can go to their official documentation website and read through it. So in this documentation, they have really explained what are the steps need to follow you to enable UART on your ESP32 microcontroller. So let's go back to program. So I will show you how two devices can communicate uh, using UART by referring to examples that is given in by ESP-IDF. So in today's video, I am referring to example which is UART asynchronous RxPS task, and the other example is UART echo. So this example can be found on Explorer, and so go to show example and open the directory, and you type UART. So you can see here there are two examples called UART echo and async RxDXR. So open these two example in separate project. So just by clicking this button, you can give the directory to whatever the directory you want to save the project, and after that it will open this example. So I have done it already to save my time. So when you are doing it, you have to follow those steps. So as I told you, first you have to open uh, those two examples in separate tabs on VS Code, and make sure you have connected your hardware devices in this manner. So I am using two H2 ESP32 H2 boards to show you this example. So this device one is another ESP32 H2 device, and device 2 is also another H2 device. So let's see how we can configure these two RxTX CPI. So I consider the first example as UART asynchronous TX RX task. So if I go through this example, what it does is it first initialize the UART configuration, and then it transfer the sample data packet called hello world, and it open the UART receive, and if something received from the RX pin, it will print the value. So it has initialized using two tasks. So one task is doing the receiving, handling the receiving task, and the other task is handling the transfer task. So to enable the UART connection, you just have to initialize these uh, parameters in this structure. And if you want more details, you can always refer the official documentation to understand this API. So in the when you open the example, the GPIO pins are different. Since I am using H2 board, I have configured this pins to that is uh, uh, pins related to H2 board. So I have configured H2 the TX pin, the transmit pin as the number 10, and the receiving pin as number 11. So basically the device 1 H2, the TX pin is GPIO 10, and the RX pin is GPIO 11. So similar way, I have configured in this second example UART echo by using configure setting. So to go to configure setting, you click this icon, and it will open SDK config, and go to example setting, and I have changed the default pins to these two values. So the RX pin is GPIO 11, and the TX pin is GPIO 10. So as you if you have noticed, so when I configure the GPIOs, I configured in similar manner. So GPIO 10 is TX pin on device 1 as well as device 2. GPIO 11 is RX receive pin, and the GPIO 11 in device 2 also receive pin. So when you configure in that way, when you connect uh, the same wire into the same pin number, it will automatically twisted as in this figure. So in that way, you can do you can make sure the uh, TX pin is always connected. In the device one, TX pin is always connected to RX pin of the device 2, and the RX pin of the device 1 is always connected to TX pin of the device 2. So that is done. So once you do the changes, you have to save it, and you have to select the uh, uh, target device in both the example and build the example file. I have done that to already done that to save the time of the video. So let's see what happened when we upload this example to those two hardware devices. So I have already flashed those this fill file to my hardware devices. So for you to do that, you just click this build flash icon. So let's open the terminal and see what is happening here in both the examples. So as you can see, this UART asynchronous task RxPS task, it sends this hello world packet to the second device, which is run the echo example. So it receives this hello world data packet from the device 1, and it will retransmit it to back to the device 1 using this while loop. So it has received this hello world and it retransmit back to device 1, which is also hello world, and you can see the receive buffer is printed in text, and you can see that is also hello world. So basically what happened is the device 1 has transmitted hello world packet to device 2, and device 2 again retransmit hello world data packet to device 1. So as I showed you in this figure. So that is simply what UART can do. So it is so we can use UART to communicate between two hardware devices, and UART is uh, mostly used to communicate uh, mainly with microcontroller and other peripheral device like GPS, GPS modules and SIM modules. So when you understand the concept, it is pretty easy to implement UART protocols such as RS485, RS232 on top of UART. So I hope you understand the basic concept behind this, and I hope you learn something from this video. So thank you very much for watching, and please subscribe to my channel. We'll see you guys later. Thank you.